Alright guys, it's Mr. Meehan. It's a chilly December day, so I am buttoned up. But here we're talking about Unit 1, Lesson 4. It says I can write conditional and biconditional statements, find the converse, inverse, and contrapositive of a conditional statement, and find the truth values for conditional statements, and complete truth tables. Alright, so let's do it. Here we go. It says problem. Determine if each statement is true or false. If it is false, provide a counter example. Statement 1 here says, if it is raining, then it is springtime. Obviously this is false, right? It can be raining during summertime. It could be raining during fall or winter, depending on where you're at. So yeah, let's say it rains a couple weeks ago. Let's say it rains during summer. Rains during summer. And let's write false. All right, number 2. It says if x and y are positive numbers, then x minus y is positive. This may seem true if you're just thinking about it real quick, right? Because we could do like 2 minus 1, or we could do like 5 minus 4, stuff like that. But what if we had a smaller number as the x and a larger number as the y, like we did 1 minus 2 or 4 minus 5? And then x minus y would be negative, right? So let's say false. Our counterexample, let's make it 4 minus 5. Those are both positive numbers, but if you subtract 4 minus 5, then you get negative 1. So that is false. All right, if water is warm, then it is boiling. I think in order to be boiling, you have to be like 212 degrees Fahrenheit. And there's a lot of examples for this, right? Like for being false, right? This is definitely false, right? Like hot tubs, bath water, showers, tea or like coffee, those aren't boiling, right? But they're pretty warm. So I'm going to write false. And my example is going to be a hot tub. Oh. All right. If a triangle has a right angle, then it is a right triangle. Is this true or false? This is true, right? That's like the definition of a right triangle. If a triangle has a right angle, then it is a right triangle. True. If your favorite color is blue, then you like to read. Well, let's think about this, right? What if my favorite color was blue and I didn't like to read? Then that wouldn't be true, right? And I'm sure there's somebody out there whose favorite color is blue and they don't like to read. All right, so this has to be false. And then if you know somebody who has a favorite color blue and they don't like to read, just write down their name as an example. You can write down, I'll write down my name, Mr. Meehan. His favorite color is blue, but he doesn't like to read. Last one, if today is Thursday, then tomorrow is Friday. This has to be true, right? The days of the week, they go in order, right? This has to be true. All right, so definition. It says a blank is an if-then statement. This is called a conditional. Conditional. A conditional is an if-then statement that relates a hypothesis, the part that follows if, to the conclusion, the part that follows then. All right. A conditional is an if-then statement that relates a hypothesis, the part that follows if, to the conclusion, the part that follows then. Note, it says conditionals can be represented as if P, then Q. It's like a P, then an arrow, then a Q. Read as if P, then Q, where P represents the hypothesis and Q represents the conclusion. All right? So that definition and that note might not have made much sense right now, but we're going to do some examples where it makes sense. All right? So a conditional is an if-then statement that relates a hypothesis, the part that follows if, to the conclusion, the part that follows then. Conditionals can be represented as P, then Q, read as if P, then Q, where P represents the hypothesis and Q represents the conclusion. And what I'm going to do is I'm going to say this is my red highlighter, and this is going to be my blue highlighter. And we're going to, in this next example, we're going to highlight each hypothesis blue and each conclusion red. So the hypothesis, I'm going to pick a different blue. I don't like that one. I'll use this later blue. Hypothesis is blue, right? Yep. And the conclusion is red. So I'm going to make all the P's blue and all the Q's red. There we go. Oh. Almost. What am I missing? That should be blue. There we go. All right. So in this example, it says highlight each hypothesis blue and each conclusion red. Also decide if each conditional is true or false. If false, give a counterexample. So remember, the hypothesis is the part that follows if. The conclusion is the part that follows then, all right? So number one, it says if you are 18 years old, that's the if part, right? So the hypothesis is the part that follows if, that has to be the hypothesis. Then you can register to vote. That has to be the conclusion. It says then you can register to vote. So if you are 18 years old, then you can register to vote. Is this true? Let's say you're in the United States, then yes, it's true, right? If you're not in the United States, then honestly, I have no idea. But in the United States, yes, that's true. So we're going to stick with that. All right, number two here, it says if a polygon is a square, then it has four congruent sides, all right? If a polygon is a square is the hypothesis, then it has four congruent sides is the conclusion. A polygon is pretty much just a non-circular shape, if you didn't know, so like a non-circular shape. So if a shape is a square, then it has four congruent sides. I think that's true, right? That's pretty much like the definition of a square, right? Four congruent sides. That works for me. Number three says if a triangle has three different side lengths, then it is an equilateral. So if a triangle has three different side lengths, that has to be the hypothesis. Then it is an equilateral. That has to be the conclusion. All right? An equilateral, what do we know about equilateral triangles? Equilateral means they all have the same side lengths, right? Or all the sides are the same in a triangle, right? All the sides are the same. So if a triangle has three different side lengths, does that make it an equilateral, right? If it has three different side lengths, are all the side lengths the same? No, right? So a triangle with three different side lengths, that's called a scalene triangle. Scalene, like that. And a scalene triangle is not equilateral. So this is false. There we go. So scalene triangles are kind of the counterexample there. If you wash your car, then it is dirty. If you wash your car is the hypothesis, then it is dirty is the conclusion. This has to be false, right? If you wash your car, then hopefully it's clean. As long as you did an okay job, right? As long as you did an okay job, then it has to be clean. So if you wash your car, then it is dirty. This is false. Because, let's say, washing cleans things. How about that? Washing cleans things. As long as you did an okay job, right? All right, number 5 here, it says you can register to vote if you are 18. You can register to vote if you are 18. This is kind of a different style of writing than what we just looked at, right? The if isn't at the beginning. Where's the if at? The if is kind of in the middle here. So it says you can register to vote if you are 18. So the if you are 18 part has to be the hypothesis. And then the rest of it has to be the conclusion. There's no then there, but the then is kind of implied. If you look at number 5 and you look at, if I zoom out here, and you look at number 1, let me draw an arrow here. These two problems, they're the same thing. They just wrote it in a different order. Number 1 says if you are 18 years old, then you can register to vote. Number 5 says you can register to vote if you are 18 years old. That's the same exact problem. They just wrote it in a different order. So is number 5 true? Yes. Number 6 says a polygon has 4 congruent sides if it is a square. Again, it's kind of in that funky order. If it is a square is the hypothesis, and that came second. That means this first part, let me see here. A polygon has 4 congruent sides is the then, that's the conclusion. And then if you look at number 2, let me see, here we go. Number 2 and number 6, they're the same thing, right? Number 6 is just a different worded version of number 2, right? So that's the same problem. A polygon has 4 congruent sides. If it is a square, that has to be true. Oh. All right. True. All right. So next idea. It says the blank of a statement is true or false according to whether the statement is true or false. So this is called the truth value. The truth value of a statement is true or false depending on whether the statement is true or false. The next blank here, it says a blank lists all the possible combinations of truth values for two or more statements. This is a truth table. A truth table lists all the possible combinations of truth values for two or more statements. So this is the truth table. It lists the hypothesis, the conclusion, and the conditional. Remember, the conditional is an if-then statement. If P, then Q, right? And we're going to determine if the conditional is true based on what the hypothesis and the conclusion are. So in the first little line there, it says the hypothesis is true, the conclusion is true. So that means the conditional, you might be able to guess, is true. We're just going to write a T. Remember, hypothesis is P, conclusion is Q, conditional is if P, then Q. For the second line, it says hypothesis is true, conclusion is false. This means the conditional is false. So if the hypothesis is true and the conclusion is false, that means the conditional itself is false. So if P, then Q is false. If the hypothesis is false and the conditional is true, if the hypothesis is false and the conclusion is true, I should say, this means the conditional itself is going to be true. So that's a little funky to understand. If we have a false hypothesis and a true conclusion, that means the conditional itself is going to be true. And then the last one, it says if the hypothesis is false and the conclusion is true, if the hypothesis is false and the conclusion is false, then the conditional is going to be true. All right? So if you're looking at this, in this note down here, it says the only time a conditional statement is false is when what? Well, if you look at this second line, that's when the conditional statement's false. So the only time a conditional statement is false is when the hypothesis is true and the conclusion is false. So let's write that in. Let's say when the hypothesis is true and the the conclusion, can I spell it? There we go. Conclusion is false. There we go. Nope. False. There we go. All right. So remember, a conditional is an if-then statement where the hypothesis is the if, the conclusion is the false. So remember, a conditional is an if-then statement where the hypothesis is the if and the conclusion is the then, right? So let's go through this example here. It says, assume each hypothesis is true and determine the truth value for each conditional. If the truth value is false, provide a counterexample. So remember, if a number is even, that's going to be the hypothesis, then it is divisible by 2. I'm going to even write in the P's and Q's too. So if P, then Q, all right? And we're assuming that the P value, the hypothesis, is true, right? That's what it says. Assume the hypothesis is true. All right, so if a number is even, we assume that's true, then it is divisible by 2. Is the conclusion going to be true then? All right, so if a number is even, then it is divisible by 2. We know that the hypothesis is true if a number is even. So we just have any even number. And then the conclusion says, then it is divisible by 2. That has to be true because that's the definition of an even number, right? So we can say the conclusion is true too. And if we have a true hypothesis and a true conclusion, then the conditional itself, if P then Q, is true. And we know that because of our truth table up here. If we have a true hypothesis, a true conclusion, then the conditional is true. All right? Let's look at number 2. It says, if a quadrilateral has 2 pairs of congruent angles, then it is a parallelogram. So if a quadrilateral has 2 pairs of congruent angles, that's the P. Then it is a parallelogram, that's the Q. So remember, if a quadrilateral has 2 pairs of congruent angles, that has to be true, right? It told us the hypothesis is always true in these examples. So the hypothesis is true, then it is a parallelogram. I'm pretty sure that if the hypothesis is true here, then the conclusion has to be true because of the definition of a parallelogram, okay? I'm pretty sure all parallelograms have 2 pairs of congruent angles. I hope I'm not wrong there when I say that. So that would mean the if P then Q statement, the conditional, that means that's going to be true. I'm going to write it like that. That means it's going to be true. If P, then Q is going to be true. Let's look at number 3. It says if a quadrilateral has a right angle, then it is a rectangle. So if a quadrilateral has a right angle, that's the P. Then it is a rectangle, that's the Q. Remember, the hypothesis is true in these scenarios. So if a quadrilateral has a right angle, let's kind of try to draw a quadrilateral. What is a quadrilateral? It's just a four-sided shape, all right? So I'm saying that's a right angle right there. Here's my four-sided shape, okay? Let's make it a little more extreme like that. And then it is a rectangle. Is that a four-sided shape that is a rectangle? No, right? It is a quadrilateral. It has four sides. It has a right angle, but it's not a rectangle. So this is going to be false. And we know that if our hypothesis is true and our conclusion is false, let's look at our truth table, then our conditional itself is going to be false, right? If the hypothesis is true and conclusion is false, then the conditional is false. So for the if P then Q statement, right? If P then Q, we can say that that is false. Number 4 says if a point X is in the midpoint, or sorry, if point X is the midpoint of AB, then X is a point on AB. So number 4, there's the P, there's the Q. We know the hypothesis is true. It says if a point X is the midpoint of AB, then X is a point on AB. Yeah, that has to be true, right? The midpoint is on the line that it's the middle of, right? So we have a true hypothesis, a true conclusion. So if we have if P then Q, if true then true, that means the conclusion is going to be true. Sorry, not the conclusion, the conditional, right? Conditional is true. The if P then Q is true. All right. So reminder, conditional statements have a hypothesis and a conclusion. And we're going into some definitions. It says a blank reverses the hypothesis and conclusion of a conditional. This is a converse. So now we have a hypothesis, we have conclusion, we have conditional, and we have converse. So remember, if the hypothesis is P and the conclusion is Q, and the converse reverses the hypothesis and the conclusion of a conditional, that would mean the converse becomes if Q, then P. Let's say if Q, then P. Just like that. That's what the converse would be. So it flip-flops them. The next definition says a blank has the opposite meaning of the original statement. This is called a negation. Negation. Like you can say you negate something. This means you take the opposite meaning of the original statement. So if we wanted to write that out, we draw a little kind of squiggle and we write the P, right? So that would say not P. Or we could say not Q. And that means we're taking the negation or the opposite meaning of something. So if the hypothesis, if the P, right, says today is Monday, then the negation of that would be today is not Monday, right? Same thing for the Q, right? So that's the negation. And it's read as, that little squiggly mark is just read as not, like it's not something. The next one says a blank negates both the hypothesis and the conclusion of a conditional. This is called an inverse. An inverse negates both the hypothesis and the conclusion of a conditional. Inverse. So what this looks like is a not P, because we're negating both the hypothesis and the conclusion. Not P, then not Q. Not P, then not Q. All right? So it takes the opposite meaning of both the hypothesis and the conclusion. And then this last definition, it says a blank negates and reverses both the hypothesis and the conclusion of conditional. This is called a contrapositive. Contrapositive. A contrapositive negates and reverses both the hypothesis and the conclusion of the conditional. That means the Q is going to come first, and it negates everything, so it's going to be not Q, then not P. Not Q, then not P. Just like that. All right? So now we have, what do we talk about? We talked about the hypothesis, the conclusion, conditional, converse, negation, inverse, and contrapositive. That's like all the definitions we're going to learn about this subject here. And we're going to go into some examples using what we just learned about those definitions. It says, write the converse of each conditional, then determine the truth value. All right? So what's the converse again? The converse says it reverses the hypothesis and the conclusion of a conditional. All right. So it makes, let me look at it one more time. So instead of if P then Q, it makes it if Q then P. My bad. If Q then P. All right? So it says write the converse of each conditional, then determine the truth value. So if you run cross country, that's the normal P. That's the beginning, the hypothesis, right? That's what we have right now. Then you're a runner, that's the Q. So here what we're going to make it say, if converse, I'm going to write a little note for us up here. The converse is if Q then P, right? So we're going to make it say, if you are a runner, then you run cross country. So if you're a runner, then you run cross country. That's what it would look like, all right? All we did was switch the hypothesis and conclusion. We flip-flopped them. And then it says determine the truth value. So is this true? If you are a runner, then you run cross country? No, it's not true, right? You can be a runner and not run cross country. False. There we go. What about number 2? It says if a polygon is a quadrilateral, then it has 4 sides. So here, that's the hypothesis. This is the conclusion. And we're going to flip-flop them to make it say if a polygon has 4 sides, then it is a quadrilateral. Is this true? Yeah, that's like the definition of being a quadrilateral, having 4 sides, right? So if a polygon has 4 sides, then it is a quadrilateral. That's true. There we go. Example here says write the inverse of each conditional and determine the truth value. The inverse, let's take a look. What's the inverse again? Inverse, if we have if P then Q, the inverse negates the hypothesis and conclusion. So it makes if P then Q become if not P, then not Q. All right? So we can say if 2 numbers are both even, that's the P. I'm going to actually write if not P up here, then not Q, just for us. So if we have 2 numbers that are both even, that's the P. Then their sum is even, that's the Q. So what we're going to write now is if we, or let's say if 2 numbers are not both even, then their sum is not even. All right? If 2 numbers are not both even, then their sum is not even. That's the inverse of it, right? That's this part. So we flipped the meaning of the hypothesis and the conclusion. We made it not P, then not Q. So if 2 numbers are not both even, then their sum is not even. Is this true? Find the truth value of this? Well, let's think about this. If we have 2 numbers that are not both even, let's say we have 2 odd numbers. Let's say we have 7 plus 7. If we have 7 plus 7, is their sum not even? No, their sum is even, right? 7 plus 7 is 14. 14 is an even number. So let's say false. The truth value of that conditional is false, or the inverse of that conditional is false. Number 2 here says, if today is a weekday, then tomorrow is Monday. That's the P, there's the Q. So the inverse of this should say, if today is not a weekday, then tomorrow is not Monday. And I can't really spell tomorrow. All right. If today is not a weekday, then tomorrow is not Monday. That's the inverse of our conditional. Is this true or false? Well, if today is not a weekday, let's say it's like Saturday, right? That's the weekend. If today is Saturday, then tomorrow is not Monday. That's true. But what if today was Sunday, right? If today is not a weekday, it could be Sunday. If today is Sunday, then tomorrow is not Monday. Well, that's false, right? So our statement itself is false. So that's a good example to say that as if the statement is false one time, then it's always false, right? If you can find one counterexample, then the conditional is always going to be false. All right, let's look at this next one. It says write the contrapositive of each conditional and determine the truth value. What's a contrapositive? Let's take a look here. It says a contrapositive negates and reverses both the hypothesis and conclusion of a conditional. So it'll say if not Q, then not P. So if two numbers are both even, that's the P, then their sum is even, that's the Q, and a contrapositive is if not Q, then not P. So let's write it just like that. So we have let's say if the sum of two numbers, if the sum of two numbers is not even, then the two numbers are not both even. All right? So that's our if not Q, then not P. If the sum of two numbers is not even, then the two numbers are not both even. So let's think about this. If the sum of two numbers are not even, that means they have to be odd, right? So let's say we have some odd number 15, where the sum of two numbers equals 15. Then the two numbers that add up to 15 are not both even. I think that has to be true, right? Because if you have two even numbers and you add them together, then the sum is always going to be even. But if you have two numbers that add up to an odd number, then one of them has to be odd, right? So I would say this has to be true. Let's look at this one. It says if today is a weekday, then tomorrow is Monday. So if that's P and this is Q, and we're trying to write if not Q, then not P, we're going to write if tomorrow is not Monday, then today is not a weekday. Now, is this true or false? If today is not Monday, let's say it's Tuesday, okay? Then today is not a weekday. Well, Tuesday is a weekday, right? So this is false, right? One counterexample makes something false. That's it. Last thing that we're really going to talk about is a biconditional. So this says a blank is a type of conditional where the conditional itself is true and its converse is true. This is called a biconditional. Let me use blue. Biconditional. A biconditional is a type of conditional where the conditional itself is true, so the if P then Q is true, and its converse is true. That's the if Q then P, all right? This results in a statement that is read P if and only if Q. And you can write this as an arrow going both ways between the Q and the P, all right, just like that. And we're going to fill in this truth table here. So here we have the hypothesis, we have the conclusion, we have the conditional, and the converse of the conditional, and then the biconditional. We already filled in this thing earlier, the conditional part. This is the same one that we did earlier. So if the hypothesis is true, the conclusion is true, then the conditional is false. If we have true and false, then this is going to be false. If we have false, then true, that's going to be true. If we have false, then false, this is going to be true. All right? Now the converse is if Q, then P, right? So that means we're going this way. If Q, then P. So for this first line, if we have true, then true, this is going to be true. If we have false then true is true. If we have true then false, that's false. If we have false then false, that's true. All right? If the conditional is... All right, so the last one is the biconditional, which is P if and only if Q. So let's take a look at the first line. It says the conditional is true and the converse is true. Remember, I'm just looking at like these two when I'm looking at the biconditional, what I should put as the biconditional, because the biconditional is a type of conditional where the conditional itself is true and the converse is true, okay? So, in the first line, is the conditional true? Yes. Is the converse true? Yes. So the biconditional is true. In the second line, it says the conditional is false and the converse is true. So since they're both not true, that's going to be false. In the third line, it says true then false for the conditional and converse. So this is going to be false since they're both not true. And then the last one, it says true then true. So this is true. So we have true, false, false, true for the biconditional. So what we can say is a biconditional is only true when the conditional and converse are both true, or both have the same value, we could say as well, truth value. So last example real quick, it says evaluate each conditional to see if it is a biconditional. If it is, then rewrite it as a biconditional, okay? So let's see if we can do this. It says if a sandwich is a PB&J, then the sandwich has bread. So if P then Q, we have to figure out if that's true. That's the conditional, right? And we also have to figure out the if Q then P. That's the converse, okay? We have to figure out if both of those are true. If a sandwich is a PB&J, then the sandwich has bread. That's the P, that's the Q. PB&Js usually have bread, right? So I'm going to say the if P then Q is true. The if Q then P, that would read something like, if a sandwich has bread, then it is a PB&J. Well, a Subway sandwich has bread and it's not a PB&J, so we can say that that's false. So the conditional is true and the converse is false. So the biconditional itself is false. This is not a biconditional. False. Not a biconditional. Number 2 says if two lines intersect at a right angle, then they are perpendicular. So if P then Q, is that true? If Q then P, is that true? Well, if P then Q is the original conditional true, if two lines intersect at a right angle, then they are perpendicular. I think that's true. That's like the definition of being perpendicular. All right? What about it if it says if Q then P? So if two lines are perpendicular, then they intersect at a right angle. I think that's true as well. So if we have a true conditional and a true converse, then we can say that this is a biconditional. So true. And let's rewrite it as a biconditional to say two lines intersect at a right angle if and only if they are perpendicular. How did I know to write it like that? Well, if you go up to the, where did it say? In the notes here. The results in this statement are read as P if and only if Q. So all I did was write the P and then the Q, and then between them I wrote if and only if. So two lines intersect at a right angle, if and only if they are perpendicular. That's how I knew to write it. Number 3 says if a triangle is an equilateral, then it has 3 congruent sides. If P then Q, that's the conditional. I think that's true, right? If a triangle is an equilateral, then it has 3 congruent sides. It's like the definition. So I would say that's true. If Q then P, this would say like if a triangle has 3 congruent sides, then it is an equilateral. I would say that's true, sure. So then it is a biconditional. The biconditional is true. So we can rewrite it to say if a triangle, actually, I lied. It would say a triangle is an equilateral if and only if it has 3 congruent sides. There we go. So a triangle is an equilateral if and only if it has 3 congruent sides. So remember, if you're writing it as a biconditional, you don't include the if and then, right? You take those out. All right, so it's just the statement from the hypothesis, the statement from the conclusion, with if and only if in the middle. The last one, if a teacher works in a school, or if someone is a teacher, then they work in a school. So if P then Q, if someone is a teacher, then they work in a school. I think that's probably true, right? Teachers work in schools. What about if Q then P? This would say if somebody works in a school, then they are a teacher. Well, that's false, right? Because it could be a principal, you could be a janitor, some sort of administrator, athletic director, something like that. So that would be false. So then the biconditional is false. There's no biconditional that we can use, all right?